It's another video. Today we're going to be looking at reactant masses 1, and that requires us to use moles to calculate masses of reactions and products of reactants and products in chemical reactions. Alright, so first we're going to look at a couple of examples, and then hopefully you can use one to actually work out yourself. Alright, so before I start this video, pretty much this is probably going to end up being a really long video for unnecessary reasons. You only need the first. If you just want to know how to do it, you can probably do it after the first example. The rest are just examples of how to do it. So if you don't need the help of 3 examples, the first example should be enough and you can go on end the video. But if you need the help, I'm doing 3 examples here, so use all 3 examples if you're struggling. But in reality, I think this is a GCSE styled question anyway, so you shouldn't be struggling if you're doing A-level. So yeah. Alright, so here we have an example. A reaction producing MgCl2 has a known mass of magnesium solid, 72 grams. Using the equation below, calculate the mass of MgCl2. Alright, so the first thing you want to do is you want to see the moles, the mole ratio. So they're giving you this, essentially here, and they want you to find out the mass of this. We know the mass is 72 grams, but we want to first find out the moles. That's the big number outside of your, or in front of your compound. There's no, even though there isn't a number here, you usually in chemistry don't write 1 Mg plus 1 Cl2. So it just means that there's 1. 0 just means that it's obviously not there. So it's 1 to 1. So one atom of magnesium can result in one mole, or sorry, 1 mole of magnesium can result in 1 mole of MgCl2. Obviously, one mole of magnesium plus 1 mole of Cl2, but it's a 1-to-1 ratio here. So just write out, so 1-to-1 ratio. Therefore, yes, it's exactly, so 1 mole of magnesium will make 1 mole of MgCl2. So if we find out the moles, they've given you the mass, so moles is equal to your mass in grams over the MR. Oh, that's a terrible sign there. Over the MR, we have the mass here, 72 grams over, let's go to the periodic table. Magnesium's in group 2, just underneath beryllium, and has 24.3, but you can round that down to 24 for AS. So 72, don't have to put the G there actually, over 24, that's equal to 24 hours, 24, 48, 72, yeah. Yeah, that's equal to 3. So therefore we have 3 moles. Since it's a 1-to-1 ratio, you don't have to multiply your moles by a certain number, you're multiplying it by 1. So 3 moles of magnesium is also going to be 3 moles of MgCl2. That's brilliant. That's probably a bit above it. But anyway, now that we need to find out the mass, the question was how to calculate the mass in MgCl2. By the way, in a real exam, you do this much quicker. But anyway, if you want to work out the mass, you can rearrange this equation here, which was moles equal to mass over. Actually, see if that makes a difference. I think part of the screen is cut off. Yeah. Okay. Good. So you can rearrange this equation, moles equal to mass over mR, into mass is equal to moles times by mR. You have your moles, which is just 3. Your mR, which is 20 of MgCl2. You want to work out MgCl2, so that's 24 plus 2 times by 35 5.5. Sorry, grade 5. And yeah, because it's two, the atomic mass, the relative atomic mass of chlorine is 35.5. So and you have two of them, so double them. So 3 times by 24 plus 2 times by 35.5, all in one bracket, should equal. Get your calculator out. Should have probably had a calculator next to me before starting a video, but so I finally got a calculator. Alright. So what's it? It was 3 times by 24 plus 2 by 35. That equals 285 grams. Yeah, that's it. That's the answer. That's it. Let's check the mark. Let's check the mark scheme or see. This is the answer here, and yeah, same answer. So that's right. Let's go on, form another one. All right, so I've got a part B to this question now. So in case you can't really see this quite well, another reaction producing MgCl2 has a known mass of another reactant, HCl, 146 grams. Using the equation below, calculate the mass of MgCl2. Now I wrote this equation. Quick note: when you're writing out equations, always leave like a little bit of space after the plus sign in case you need to add like a moles when you're balancing out your equation. If there's nothing there, the examiner won't really get onto if there's a small gap there, because that's just you showing that you understand that you might need to add a 2 or a 1 before the molecule. Anyway, so the first thing you do, they're giving you the mass of this this compound here, HCl, hydrochloric acid, and they want you to work out magnesium chloride here, MgCl2. So the first thing you want to do is find out, are my two sides balanced? Or you can just, I don't know how you guys balance, but the way I balance is I put a line here, and then I get out all my molecules: Mg, oxygen, hydrogen, chlorine. I got speed today. Alright. And then do the same for the other side. You should do this much faster. H and chlorine. Hopefully you can see that. And I quickly jot it down. This usually takes me less than 20 seconds if I'm doing it quite fast. But oxygen is 2 because it's OH2 all in that bracket. 2, hydrogen 3 because we have the HCl there as well. So that's 3, and that is equal to 1 here. So then other side, your magnesium is 1, oxygen 1, hydrogen 2, CO2 is 2. So as you can clearly see, it's not balanced because there's not the same number of molecules on each side, and due to the law of conservation of mass, there has to be the same number of molecules on each side of the equation. How can we do that? So the number of magnesium hasn't changed, so it's unlikely that we have to change something here, but keep that in mind. Oxygen has changed. Yeah, oxygen concentration has changed. So that means, so in that case, we can add a 2 here, 2 H2O. That means we have a 2 for that. Hydrogen now becomes 4 on this side. That's fine. 2 H2O here. And now we have to look at balancing, make sure everything's balanced out. We have 1, 2, 3, 2, 3 on this side. Chloride is also 2, is also 1. So we need to double this to make sure it's 2. So 2 HCl. That would make sure that's 2, 4, 4, and 2. In reality, you should be doing that like in less than a minute. Usually it's 1 minute for balancing equations. They do get questions like that. But now that's balanced. We have MgOH2 plus 2 HCl goes to make MgCl2 plus 2 H2O. And you can see on both sides there's the same number of molecules on either side of the equation. So we know it's balanced now. But we have to remember what we're actually looking for and what we're not looking for. So we're looking for trying to find the mass of MgCl2, given that we have the mass of HCl. The mass of HCl was 146 grams. Just here. But we have to think about, it's a 2-to-1 ratio here. 2 hydrochloric acids then going to make MgCl2. So you have to write down 2-to-1. Magnesium hydroxide here is negligible, so it's not really what we're looking for. You can assume it's in excess, so you just assume it's in excess. Alright, excess there. So moles, we have to work out the moles to find out the mass. The moles is equal to the mass over the MR. Moles of HCl equals to its mass 146. Don't know if you can see that there. In case I forgot, you can see that now. It's 146 all over its MR. Chloride is 35, chlorine is 35.5, and hydrogen is 1, so it's just 36.5. Use a calculator to work out the moles of HCl. That should be equal to, alright, so 146 over 36.5 equals 4. That perfectly equals 4. Sorry, it's at an angle. I'm writing this at an angle because of my tripod, but it should be fine. You have 4. But you have to remember it's a 2-to-1 ratio, so you're having 4 moles for every. So since it's 2-to-1, in order to get the moles of MgCl2, we have to divide by 2. To get from here to here, 2-to-1, divide by 2. So 4 divided by 2, just 2. So 2 moles of, you have 2 moles of MgCl2. Mass is equal to, if you rearrange this equation, moles times by the MR. Something like that. Moles mass is equal to you have 2 here, and MR of MgCl2. This is a part B, so you can use the exact same one as last time. Did they give me the MR of last time? Yeah. 24 plus 2 times by 5.5, so don't remember off the top of my head what that was, but 2 times by 24 plus 2 by 30. You know what? I haven't even got enough space here. Let me go to the next page. Mass equals 2 times by 24 plus 2 by 35.5. And that equals that equals 190 grams. So that should be our final answer, 190 grams. Let's see if I got that correct. As you can see here, it is 190 grams, so that is the correct answer. Just get that there. Yes, working out is correct as well. So, alright, so this is going to be another question here. Calculate the mass of Na2SO4 produced from 240 grams of NaOH. Assume sulfuric acid is in excess. So there might be an occasion, they usually don't give this occasion anymore, but there might be an occasion where they don't even give you a formula to write. They expect you to make the formula yourself. This one luckily isn't too difficult. So calculate the mass of Na2SO4 produced from 240 grams of NaOH. So let's see what happens when you add these together. So you get NaOH, maybe we leave a little gap here. Oh, we should probably make it a little bit closer so you can all see it. Yeah, so make sure leave a little gap here so that in case you need to add a low number. But concentration, so NaOH. They said sulfuric acid was in, I should probably, did I say it? Okay, I didn't write it down, but okay, sulfuric acid is in the reactant side. I should have probably put that in, but sulfuric acid is H2SO4. Usually form. It's an acid, so it's probably aqueous. Acid is also aqueous. Alright, and that goes to form sodium sulfate, Na2. So it goes to form Na2SO4. Let's look at what we have over. So we have H here, H2SO4, positive balances ionically. There probably is a water involved. Let's try that. As I said, I don't know. I haven't seen this question in a really long time. So I got this here. So NaOH plus H2SO4 goes to make Na2SO4 and then plus H2O. This obviously isn't balanced. Let's balance it out. Get ourselves here. Yes, Na. Actually, you know what? You work it out from here. Let's see if you've learned anything from this. So I'll pause the video now if you need anything, or if you need to obviously answer the question. But pause the video and see if you can answer it yourself based on the information you have. And I'm gonna continue from now on, assuming that you've answered the question. So yeah. Right. So Na. So you have NaOH. So Na is one of them. Oxygen, hydrogen, sulfur. Those are all the elements on the left hand side, and that should also be the same. Has to be the same on this side if law of conservation of mass. Have I missed anything? No, I have not. Great. There's one atom here, one atom here of sodium, hydrogen, sulfur. Oxygen is 5, hydrogen is 3, sulfur is 1, Na2, 5, hydrogen is 2, sulfur is 1. So we have 2, 1 here, so that's not balanced. Hydrogens aren't balanced, so it's 2. There's now, there should be 4 here, so it should be 2. Yeah, that's 4. 2, 5, and 2. Hydrogen, so we can just put this, make this 2 here. Oxygen now will be 2, so that's 2, 6. That's now 6. How can I balance out? That's 2 oxygens here, so that's actually 6 as well, so you balance out, yeah. 2, 6, 4, 1. Yeah, that's perfectly balanced out. Alright, and then you can go on to do moles. Moles is equal to your mass over your ml. Sorry, I'm making sure not to make any mistakes on this, so I don't get in trouble for it or anything like that. I won't get lots of comments saying I've done it wrong. They've given you NaOH. Yeah, they have given you NaOH. So they've given you 240 grams of this compound here. There actually isn't anything here right now, so I can just leave that as that. 2 NaOH to make 1 Na2SO4, 2:1 ratio. Moles equal to mass of the MR. Mass is 240. Sodium, I believe, is 23 plus, and then plus 16 plus 1, so 23 plus 16 plus 1, but just to be sure. It is 23. And then you can just put that all to get your moles. 240 over 23 plus 16 plus 1, or that gets you 6 here, in case you haven't seen it. That's 6, but your moles to, it's a 2:1 ratio, and if giving you 2 on one side, so you have to 6 divided by 2, that's 3. 3 moles of Na2SO4. And then you just work out it normally, so your mass should be equal to your moles times by your MR. And then when you do that, you should get, why am I doing this like this? 3 times by 2 times by, let's put it all here, 23 plus 32 plus 16 times by 4. I think 30 itself is 32. Pretty certain it's sort of 32. Yep, 32.1. Fine, doesn't matter. Yep, and then that's keep as that is. And this should just give you your final answer. And you put that into your calculator. So in real life, they'll give you probably 3 minutes to answer this question. So maybe less, probably less. It might be it might be one of those situations where you have to do 1 minute multiple choice questions. So you probably have to be faster at this. I'm just doing it. You should be doing it at half the speed that it takes me to do it. Half the speed? Half the time that it takes me to do it, not half the speed. I'm just doing it because I want to make sure I get through every single point. Yeah. 426 grams. That hopefully is the final answer. I have to make sure if I don't make any mistakes. 426 grams. And that's your final answer. So yeah, that's it. Hopefully found this video useful. Yeah, next one. Safe.